what I want to do first, I want to do a couple examples of how to find some really tough domains. I'm going to expect you to be able to do domains, pencil and paper, without using a calculator. And these, when you have a squared inside the radical, they pose a kind of different and unique challenge. So there's a specific way you're going to have to do that and show me how to do it. And it's a little different because of the inequalities involved. And then we'll have this crazy fraction inside there too. And this is kind of similar in the idea behind it, why we do it the way we do. So the domain part you're going to have to do without the aid of a calculator and show me the correct work. The range stuff I'm going to let you use the calculator for. We won't try to do it there. We'll just talk about these two right there. But it's even with the calculator, it takes a little bit of interpretation. So I want to make sure that you see what kind of things you're going to have to do to kind of unravel the mystery here. Okay, so first one we have, so I'm going to do the domain first. And I'm going to do the domains on each of these. And then I'm going to come back and do the ranges, because then I'm going to try to play around with the camera so that it shows my TV screen, which is going to display the calculator. And hopefully I won't cut off the video while I do that. So as before, the issue here is because we have the radical. So it's an even index of square root, fourth root, sixth root. So that means what's inside here cannot be negative. So we take the 9 minus x squared, the thing inside the radical, and we say that has to be greater than or equal to 0. Now, it is not okay to do this exactly the same way you would do it as if that was an equal sign. If that was 9 minus x squared equals 0, it would be perfectly okay to add that x squared to the other side, to take the square root of both sides and look at all possible solutions and get x equals plus or minus 3. That does not work with an inequality, because when you take the square root of both sides, you don't know what's going on with the inequality. Is it less than? Is it greater than? Is it in between, outside? As we're going to see, there is not a good, meaningful way to interpret that result. As a result, you cannot do this with the inequality and get credit on the test. Okay? So instead, we have to do this skill that becomes really important for us next year down the road. We'll employ this technique, this analyzing the sign, a lot. So instead, we're going to factor this. So we have two ways you can do that. If you do it at face value, you can just call that the difference of two squares and call it 3 minus x, 3 plus x. Some people get bothered by the negative there, and so if that's the case, alternatively, you could factor that negative out if you want to make it look like negative quantity x squared minus 9. And some people feel better about factoring that and leaving that negative outside, and then they can do this x minus 3, x plus 3. Okay. I don't care which way you do it, but show me how you're going to do that. Now, what we're going to do next is we're going to do a number line here. Now, big picture, this 9 minus x squared, which is represented by either one of these factored quantities here, this can change. So what this really saying is, where is this positive? Well, this is a continuous function, which means we know it's a big parabola. So when you draw it, you never lift your pencil from the paper. So therefore, it will never change from positive to negative or negative to positive without passing through 0. Right? It can't go from positive to negative and skip 0. It's got to go through 0. Likewise, it couldn't go from negative to positive without going through 0. So the places where this is equal to 0 are going to be boundaries in our domain, or potential boundaries. So this could be equal to 0 when x is 3, and this could be equal to 0 when x is negative 3. We okay so far? I need nods of heads. Okay, so on the number line, I'm going to go to negative 3 and positive 3. That's where this is going to be equal to 0. Because this is a greater than or equal to 0 counts as a solution. It's going to be part of the domain, so I'm going to make those be solid dots. They're included in our domain. Now these zeros divide our number line into 3 regions, left, middle, right. Now these are like the gateways. These are the only places that this could change from positive to negative or negative to positive. So if I take any representative from this region and plug it in here or anywhere I like, if it turns out to be positive, everything here is positive because it couldn't change unless it goes through 0. If I take a representative here and I plug it in there and it's negative, everything here makes this negative. See the logic behind it? Okay, so then I'm going to take whatever, I'm going to take -4. So if I plug it in here, 3 minus -4 is going to become a positive. I don't really care what the number is. All I care about is the sign. Is it positive or negative? 3 plus a -4 is a negative. Now these are being multiplied together. You with me here? Positive times negative is negative. That is not greater than or equal to 0. That means everything here will make this be negative. Nothing here is going to be in the domain. I'm going to leave that blank. Now, if you like doing it this way, we can still do the same thing. If I plug in a -4, -4 minus 3 is a negative, -4 plus 3 is a negative. We still have that negative. A negative times a negative times a negative. 3 negatives is negative, which is going to be negative, which is also not greater than or equal to 0. So we're going to get the same result. It's just what makes you more comfortable, how are you better able to get to this point. So what we're doing here is analyzing the sign of this, the sign. Is it positive or negative? Now I'm going to take a representative here. 0 is a nice choice. Now 3 minus 0 is positive still. 3 plus 0 is also positive. See how I'm doing that? Positive times positive is positive. That is greater than or equal to 0. That means everything in here is going to be in the domain. That is a solution to this inequality. And then if I take a representative from the far right, say 4 or 400, it doesn't matter. 3 minus 4 is negative. 3 plus 4 is positive, and a negative times a positive is negative. Nothing's in the domain there. Now I see a graph of the solution set. I see a graph of all the numbers in the domain. So now we have to write what that is. So you can either use your inequality notation and say -3 less than or equal to x less than or equal to +3, or you're welcome to use that interval notation and use the brackets from -3 to 3. Are we okay so far? These are tough. Now, you cannot jump somehow to this. I'm not looking for intuition. I'm going to let you in a problem like this use your graphing calculator. Maybe I'll just make it a separate problem, but maybe it'll be like that. And you can do the range. We'll do the range separately here in a minute. I'll come back to this problem. But you have to be able to do this pencil and paper. You have to show me the number line. I have to see how you factored it if you're going to get full credit. You give me the correct answer and I don't see the supporting work, that's not worth anything. And you're not going to get points for that. This process we will come back to over and over again next year as well. It applies to other kinds of problems than just domain problems. We're going to use it in domain, but there are other places where it comes up as well. So now, we'll see what this looks like. We start the same way. X squared minus 16 has to be greater than or equal to 0 because that is sitting inside a radical. Again, we can't just add the 16 square root both sides. That doesn't give us anything meaningful. So instead, we're going to factor this as the difference of 2 squares. We're going to draw the number line. And where will this be equal to 0? Negative 4 and 4. So do we put solid dots or open circles there? Solid dots because those will make this equal to 0, and the square root of 0 is defined. We got 3 regions. What do you want to pick from the far left region? Anybody?
-6.
-6. -6 minus 4, is that positive or negative? Negative. -6 plus 4, is that positive or negative? Negative. A negative times a negative is positive. That is greater than or equal to 0. Now on this one, the domain is going to be out here, different than the one we just did. Okay, different domain completely. Represented from the middle region, anybody? 0 is a great choice. 0 minus 4, positive or negative? Negative. 0 plus 4, now we're positive. Negative times a positive is negative, not greater than or equal to 0, not in the domain. Represented from the far right region? 6. 6 minus 4 is positive, 6 plus 4 is positive, positive times positive is positive. That's going to be in the domain. Okay? Now we have to write this. So our domain is going to be, just as you see this is in two pieces, you look at that and see it's in two pieces, we have to have two separate inequalities here. There is no way to correctly write this. I call these like a double inequality where it's all in one line. We can't do that here. There is no way to do that. So we have to say this piece is going to be x less than or equal to negative 4. We need the word or, not and, or, and then this piece over here is an x greater than or equal to positive 4. You cannot combine these in any correct way like that, like we did over there. Here we have this stuff in between negative 3 and 3. We could write the inequality as that in between. Here we have the outsides. We have to have two separate inequalities. Questions so far? All right, now the same idea of doing the sign analysis is now going to apply to this big crazy looking fraction. So now we're going to jump right to the number line. Now a fraction, this fraction inside here, what we're trying to solve is this x minus 2 over x plus 1. We want to be greater than or equal to 0. So we're still looking for those answers. Now, we said in this factored form that this could only change sign from positive to negative or negative to positive if this was 0 somewhere. Well, now what we get, remember, this is going to be undefined when the denominator is 0. A place where it is undefined is also a place where it could change from positive to negative or negative to positive. So we want to know where is this equal to 0 and also where is it undefined. Those are going to be our boundary points. Those are going to be our gates where it could change on either side. It doesn't have to, but it could change on either side of those. So a fraction is equal to 0 when its numerator is 0. And its numerator is x minus 2. And if we say x minus 2 is equal to 0 at what value of x? 2. Now, if this is equal to 0, it is defined in the radical. Square root of 2 is, square root of 0 is defined. So this is a solution, so it gets to be a solid dot. This will be undefined when the denominator is 0. What value of x makes the denominator 0? Negative 1. So I'm going to put it left over here. Now, when this is negative 1, this thing is undefined, and so therefore it cannot be in the domain, and so it's going to get an open circle. See the big difference so far? Okay, numerator, solid dot, denominator 0, it's going to be an open circle. Now we have the same thing. At these places, this could change from positive to negative or negative to positive. So we have to test these regions. So I'm going to check the left region. What do you want to use? Negative 2 is good. Now, we're looking at numerator, denominator. Is that going to be positive or negative? So we plug in a negative 2. Negative 2 minus 2, is that positive or negative?
Negative.
And negative 2 plus 1, is that positive or negative? Negative. Now, a negative divided by a negative, is that positive or negative? So that is going to be positive. So that is greater than or equal to 0. So we're getting, again, like we saw in that second example over here, we're getting that outside part. With me? Representative from the middle region. 0 is nice. So here when you plug in 0, 0 minus 2 is negative. 0 plus 1 is positive. A negative divided by a positive is, and that's not greater than or equal to 0, so we get nothing from for the domain out of this. Representative from the right-hand region. 3. So 3 minus 2 is? 3 plus 1 is? Positive over positive is positive. So there's going to be our representation of the domain. Now we have to actually write that. So now we have the two pieces again, like we did the middle one, but now the first one is not the solid dot. So we're going to call that what? X is strictly less than negative 1. The word we have to use in between here is or, and we get x is greater than or equal to 2. Nice. Okay? These are as tough a domain problem as we're going to see, but you will see these. Yeah, I expect you to be able to do these kinds. We'll try to work some more examples in future days as we go. Now let's turn our attention to range. Because as tough as the domain is, the range is harder. And so I'm going to not insist that you do this pencil and paper, but I'm going to let you use your graphing calculator. But even with a graphing calculator, it's not going to be trivial. It's not going to be like, oh, I got it, it's easy. You're still going to have to think about it and maybe do some interpretation. So we're going to put y equals 9 square root of 9 minus x squared on your calculator. I'm going to do that on mine. I'll put it up here, and then I'm going to try to play around with the camera so I can show my calculator screen, hopefully without cutting off the video, which I have a tendency to do. So we'll see how that all plays out. All right, so I'm going to go y equals, clear off that old junk. We're going to go square root of, and then we have 9 minus x to the second, and then I can just write it. Okay, there we go. Now let's choose for a domain here. Let's choose for a window. Let's go, I think we'll see everything we need to from -5 to 5 on the x. So I'm going to go -5 to 5. The scale is the tick marks. I'm going to leave those at 1. And for the y min, I'm going to go -1 and up to a +5 for the y max, and I'll leave the tick marks there. So I'm going to go ahead and hit graph, and then I'm going to try to turn my calculator around, but I got to use too much technology here.